All right, so tomorrow's experiment, we're going to be looking at hydrates. And what hydrates are salts that have water molecules, H2O water molecules, embedded within the crystal structure of the salt. So the water gets stuck into the crystalline structure of it. Okay? And having those waters there, number one, makes it heavier than it would be without those. Okay? And then it also, a lot of times, gives it a color or characteristic. Okay? And so we're going to be investigating different hydrates. And to determine a true hydrate, you have to first get rid of the water. So evaporate the water from it. And then you add back the water to it. Okay? And if it goes back to its original color, then you can determine it to be a true hydrate. Okay. So if you look at Part B, let's go there. Let's start there. Part B of your report sheet. Okay. You're going to have different compounds. Nickel 2 chloride, sucrose, sodium tetraborate, copper sulfate. So I'm sorry. Where it says potassium dichromate, we're going to be using a substitute copper sulfate instead. Okay. So you can rename that. And then the last one is potassium chloride. Okay, so you can see here you're going to fill out this chart. The color before the heating. So some of these are going to be very colorful. You're going to have some greens and blues. Okay. So you're going to describe that color before. Some of them might just be white. Okay, but that doesn't mean it's not a hydrate just because it's white. So you'll record the color of it. And then as you're heating it, okay, you'll notice that, so you're going to heat it the same way that we heated our test tube today. Okay? And as you heat it, if water condenses at the mouth, then that means water is being drawn off of the salt and it's evaporating, and where it gets cooler up at the mouth of the test tube, it condenses and you'll see the water forming at the top. Okay, so that's what it's asking. Does water up here with heating? So if this is your test tube, okay, here's your hydrate down here. Okay, the water will evaporate, and up here at the rim, you'll see the water droplets starting to form. Okay, that's an indication that it's a hydrate. That's not the only indication that it's a hydrate, because other things, as they decompose, also form water as a product, and that could be also condensed. But that's one of the tests. Okay? So, you'll say yes or no, water is forming at the mouth. Okay? Color and texture, the residue, so you'll describe that, is the solution, is solution of residue, same color as solution of original compound. So this confuses people what they're talking about. So what they mean is that, so for nickel chloride, so I will have a test tube with some nickel chloride dissolved in water, okay? And it will be a certain color. So let's say that it has a greenish color to it. Okay? So you guys, so this is in water and it looks green. What you guys do is, after you've heated these up and you've drawn off all the water and they're kind of colorless, they were kind of green before, you drew off all the water and it became colorless. Then you dissolve that colorless salt into water. You dissolve it in water. And if it matches the key that I'll have up front here, if the color of the one that you dissolved So it goes white, you dissolve it, and it turns back to green. Okay, and it looks the same as this one that I have up front here. Then that means that they are the same color, that the solution of the residue is the same color as the solution of the original compound. Yes. That's when you would say yes. So you're going to compare the solution that you make for that to the solution that I'll have up here, okay, of those. All right. Is the compound a true hydrate? So to be a true hydrate, number one, the water needs to appear at the mouth, and it needs to be the same color solution. So you have to have yes in both of those places for it to be a true hydrate. So if water appeared at the mouth, but the solution doesn't go back to its original color, then it's not a true hydrate. Okay? Or if the solution, the original solution is the same as the final solution, but there was no water appearing, then it's not a true hydrate. Okay, so you have to have yes in both of those columns for it to be a true hydrate. Okay, then we will also be doing a procedure similar to the one that we did today. Okay, so you'll see here that we're going to be taking a hydrate, and what you are going to is you are going to determine the number of water molecules that are embedded into the compound of that hydrate. Okay? So the one we're going to be using is nickel. Oh, let me turn it back. We're going to be using nickel sulfate or nickel 2 sulfate. Okay? And you are going to determine the times X H2O. So this is what you're going to find. How many water molecules are there? So is it what number goes here? Is it 2, 3, 5, etc.? What is that number? So the same way we did today, you heated it up, and what happened to the mass? It decreased. You're going to do the same thing here. You're going to heat it up, and the mass is going to decrease due to what? What's going to happen? Why is it going to decrease? The water will evaporate. The water has mass to it, and as you heat that water up and draw it off, the mass will decrease. And so you can figure out how many waters came off by that procedure. So look at your report sheet. So you see how it's pretty much the same thing that you did today? But they're using a crucible. We might change that. We might use just a beaker. Since you guys are so familiar with it, it's really easy to use. We might just do the same thing. Okay? Maybe. I haven't quite decided. I've never not used the crucible, but the crucible is just, it's harder to use, and it's just, so I might want to see how it works with just using the test tube. I anticipate it will work well enough. Okay? So, do the same thing. You're going to draw those waters off. You're going to find the mass. After your final cooling, you'll find the final mass, and then you compare it to the original mass to determine how much water, right? So mass, so here where it says mass of anhydrous salt, so let's count, let's label them down again, just like we did today. Okay? So we have 1, 2, 3, 4, 5, 6, 7, 8. Okay? So I've gone to 9. I have 9 things labeled. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay? Mass of anhydrous salt is my 7. Is that your guys' 7? Did you label it the same way I did? Say it again. So did you label mass of crucible plus lid plus residue as a number? Okay, so is everybody online with me then? Number 7 is mass of anhydrous salt. So anhydrous salt, anhydrous means the salt without the waters, the dry salt. Okay, so if it's the anhydrous salt, then to find out the mass of it, I need to know the mass of the water lost, which is number 8. So you actually have to figure out number 8 before you figure out number 7. Okay, so number 8, to figure out number 8, you're going to subtract the mass of crucible plus lid plus unknown, which is number 1. So to find 8, you're going to take number 1, and you're going to subtract the mass of the dry salt, which is the mass of the anhydrous salt. I'm sorry. So 1 minus 7. So actually, number 6, which is your cold final mass. Okay? So same thing you did today to find the oxygen, right? You took the mass of the initial setup and subtracted it from the mass of the cold heated. After you heated the final heating, the cold mass of that, you subtracted those to find the oxygen. You're doing the same thing to find the mass of the water lost. Okay? So it would be 1 minus 6 to find that. Then to find the mass of the anhydrous salt, you would take the mass of the unknown hydrate, which is 3, and you would subtract the mass of the water lost, which would be 8. So you would take the mass of the unknown hydrate, number 3, and subtract the mass of the water lost, which is number 8. That's for the mass of the anhydrous salt. Say it again. I do want you to, that's the only one I care about. I don't care about, just same again, I don't care about all the other heatings. Those are simply so you can find 2 that are the same, and then let it cool all the way down and give me that final mass. That's what I care about. Okay? Okay. Percent of water in the unknown hydrate. Now, if you turn back in your report sheet, the next calculations are all shown to you very clearly. Okay? Do you see on page 99, number 7? Percent H2O. Mass of water lost over mass of hydrate sample. It's all set up for you very easily. Okay? So you would do that. Formula of unknown hydrate. So I would give you a formula. I think you can just simply write that formula. Nickel sulfate X H2O. So we'll figure that out tomorrow, what that X is. Okay, so that's what you would write here. NiSO4 X times X H2O. Okay, moles of water and hydrate sample. So to find the moles of the water in the hydrate sample, once again you turn to page 99. Oops, I'm sorry. Not page 99. Moles of water. You know the grams of the water, right? Grams of water is number 8. And you're going to convert 8 to moles. Okay? Number 8 you're going to convert to moles. And that's the moles of the water. The moles of the anhydrous salt, same thing. You're going to take the moles, the grams of the anhydrous salt, which is number 7, and you're going to convert that to moles. So you have both of those. And then to find X, okay, back on 99, To find X, you're going to take the moles of the water divided by the moles of the salt, anhydrous salt, and then you'll be able to write the complete formula, replacing X there with whatever number you come up with after you divide the water over the salt. Okay? And that's how you're going to find the complete hydrate formula. Okay, so this is how we're going to investigate hydrates tomorrow. Like I said, it's going to be very similar to today's setup. So you can kind of just come get this set up. When you get here, you can even start grabbing the materials and things you need. Get your test tubes, your beakers, your ring stands, your clamps. Okay, you can start getting all that ready. And then you're going to need a test tube rack with 1, 2, 3, 4, 5 test tubes. Okay, because you're going to get a sample of each of the different chemicals, just a little sample, a pea-sized sample of each of them in the bottom of that test tube. But you don't have to weigh it for this part B. You don't have to weigh it. You just need to get a small sample into each test tube. Okay, and then you will heat those and make your observations, and then you'll add water to the heated dry sample of that, and see if it goes back to the original color. Okay. Okay, so when you get here, you can start getting that set up ready. Any questions?